Picture this: a single AI model, running quietly overnight, reads through millions of lines of code and flags a security hole that a team of seasoned engineers stared straight at for 2 years and never noticed. That is not science fiction. That is exactly what Anthropic's brand new open-source framework is built to do, and 2 days ago they gave it away for free. The project is called the Defending Code Reference Harness, and it landed on GitHub on the 4th of June. Now, that name sounds like a mouthful, so let me translate it into plain English. A harness, in software, is just a frame that holds a tool steady while it works, like the scaffolding around a building. This particular harness holds an AI model steady and points it at one job: finding the cracks in software before the bad guys do. For decades, hunting for security bugs has been slow, painful, expensive human work. The best researchers in the world can spend weeks chasing a single flaw. Anthropic is betting that a large language model, given the right structure, can do a chunk of that work automatically at a scale no human team could ever match. And here is the detail that made security researchers sit up straight. They did not keep it locked behind a paywall or an enterprise contract. They published the whole thing, open source, for anyone to download tonight. But here's what most coverage gets wrong about why they did it. To understand why this matters, you have to understand how broken the old way is. Right now, the world runs on software, and that software is riddled with hidden flaws called vulnerabilities. Think of a vulnerability as an unlocked window in a house that looks completely secure from the street. The front door has 3 locks, the alarm is armed, but one window around the back was left open by accident, and a burglar who finds it walks right in. In code, those open windows are everywhere. By some industry estimates, professional software contains roughly 15 to 50 bugs for every 1,000 lines written. A big application can run to 10 million lines. Do that maths and you are staring at potentially hundreds of thousands of weak points. For years, we have relied on 2 things to catch them: automated scanners and human experts. The scanners are fast but dumb, drowning teams in false alarms. The humans are brilliant but slow and scarce, and there are nowhere near enough of them. The gap between how much code we write and how many experts we have keeps widening every single year. Attackers know this. They only need to find one open window. Defenders have to check all of them. That asymmetry is the entire reason cybercrime is projected to cost the world over $10 trillion a year. Anthropic looked at that broken equation and asked a simple question. What if you could clone your best researcher 1,000 times? Here's the twist nobody expected in how they answered it. So how does this thing actually work under the hood? Let me walk you through it the way Anthropic designed it. At the center sits a large language model, the same kind of brain that powers a chatbot, but instead of writing poems, it is told to think like an attacker. On its own, an AI model is like a genius detective locked in a featureless white room with no case files and no tools. Brilliant, but useless. The harness is what hands that detective the evidence and the equipment. It feeds the model chunks of real source code, gives it the ability to run searches across a codebase, lets it take notes, form a theory about a possible flaw, and then test that theory step by step. Crucially, it forces the model to show it's working. Every claim it makes about a vulnerability has to come with a concrete trail of reasoning a human can check. This solves the single biggest problem with AI security tools, which is hallucination. An AI that confidently invents a fake bug is worse than useless, because it wastes the precious time of the humans reviewing it. By demanding evidence at every step, the harness filters out the daydreams and keeps the real findings. It is the difference between a detective who shouts a random name and one who lays out the fingerprints, the motive, and the timeline. Anthropic reports the structured approach dramatically cuts the false positive rate. But here's the kicker about what they tested it on. Let me make this concrete with what actually happened when they ran it. Anthropic did not just publish theory. They pointed the harness at real, widely used open-source projects, the kind of code that quietly sits underneath apps and websites you use every day. And it found genuine, previously unknown vulnerabilities, real open windows that nobody had spotted. Take one category they highlighted: a class of bug where a program trusts data it should never have trusted, letting an attacker slip in a malicious instruction disguised as ordinary input. In plain terms, imagine a bouncer who checks ID at the door but waves through anyone wearing a staff lanyard, never noticing the lanyards are being printed in the car park. The AI traced exactly how that trust could be abused, line by line, and produced a report a human engineer could verify in minutes instead of days. In another run, the harness chewed through a sprawling codebase overnight and surfaced issues that had survived years of human review and existing automated scanners. Think about the economics for a second. A skilled penetration tester might charge well over $1,500 a day. The model can run continuously for the cost of electricity and compute, never gets tired, never gets bored, and never skips the boring file at 3 in the morning where the real bug is hiding. That tireless patience is its secret weapon. And this is where things get surprising, because the same power has a darker mirror image. Here is the tension at the heart of this whole story. A tool that finds vulnerabilities for defenders is by definition also a tool that finds vulnerabilities for attackers. It is the exact same skill pointed in opposite directions, like a master locksmith who can either secure your home or crack any safe in the city. So how does Anthropic's approach compare to what came before and to what a criminal could build? Traditional scanners, the tools companies have used for 20 years, work off fixed rules. They look for known patterns, like a guard with a printed list of wanted faces. If the bug does not match the list, it sails right past. They are cheap and fast, but blind to anything new. Human red teams are the opposite. They are creative and can find truly novel flaws, but a top firm might cost a company hundreds of thousands of dollars for a single engagement, and they can only review so much. Anthropic's harness aims to land in the sweet spot between them, the creativity of a human researcher with the tireless scale of a machine. Early signs suggest it can reason about genuinely new bugs, not just pattern-match old ones. But the obvious worry writes itself. If a defender can download this tonight, so can someone with bad intentions. Anthropic's bet is that putting it in the open helps defenders more than attackers, because the good guys have far more code to protect. But here's what the headlines aren't telling you about that gamble. So what does this actually mean for the world outside the security industry? Let me zoom out. If AI can reliably hunt vulnerabilities at scale, we are looking at the beginning of a genuine arms race, and the starting gun just fired. On the defensive side, the upside is enormous. Companies that protect your bank details, your medical records, and your messages could soon run an AI auditor across their entire codebase every single night. Catching flaws before they ship, instead of after a breach, makes the news. That could slash the window of time attackers have to exploit a fresh bug from months down to hours. For ordinary people, that means fewer of those alarming emails that begin with the words "your data may have been compromised." But the same logic cuts the other way. Less sophisticated criminals, who could never afford an elite hacker, might soon rent an AI that does the heavy lifting for them. The barrier to entry for finding exploits could collapse. This is why Anthropic framed the release the way they did, leaning hard on the word defending right there in the name. Their thesis is that defenders benefit more from this technology than attackers do, because there is vastly more software in the world to protect than there are specific targets worth attacking. Whether that optimistic bet holds up is one of the most important open questions in technology right now. And this is what nobody predicted about who moves first. Alright, so what can you actually do with this? Whether you are a curious developer or just someone who wants to understand the shift, let me walk you through it. First, if you write code, the framework is sitting on Anthropic's GitHub right now, free to clone. You point it at a repository, connect it to a capable model, and let it begin its overnight audit. You do not need to be a security specialist to start. The whole point of the harness is that it carries the expertise for you. Think of it like hiring a tireless junior researcher who happens to have read every security paper ever written. Second, and this is the part worth internalizing even if you never touch the code, treat any AI security finding as a lead, not a verdict. The harness is deliberately built to show its reasoning precisely so a human can confirm it. Always verify before you act. Third, for everyone else, practical takeaway is about timing. Expect the software you rely on to get quietly safer over the next year as companies adopt tools like this, but also expect attackers to move faster. So the boring advice suddenly matters more than ever. Update your apps the moment a patch lands, because that patch may now be racing an AI that found the same hole. Turn on automatic updates and stop hitting "remind me later." That single habit is your personal front line. But there is one last thing you need to understand before you go. So here is what this all means for you and what to watch for next. 2 days ago, Anthropic quietly changed the economics of cybersecurity by handing the world an AI that hunts software flaws and refused to charge for it. Strip away the jargon and the story is simple. For the first time, the tireless scale of a machine has been pointed at the single most expensive, most human problem in technology, finding the cracks before someone else does. The defenders just got a powerful new ally, and so, uncomfortably, did the attackers. Which side benefits more is the multi-trillion-dollar question we will all be living inside for the next few years. My honest read is this: the release is a starting gun, not a finish line. Watch over the coming months for 2 signals. First, how many real vulnerabilities in major software get credited to AI tools like this one, because that number will tell you how fast the defensive side is winning. And second, watch whether other labs and security companies build on this open framework or rush to lock their own versions away. The fact that Anthropic chose open over closed is itself a bet about how this future should unfold, and not everyone will agree. If you found this useful, follow for daily AI news, because this is the kind of shift we break down every single day. The arms race just began, and you are now ahead of almost everyone in understanding it.